That little twitch in your eyelid after the gym? Everything you've been told about it is wrong. Those aren't tired muscles. They're panicking neurons. You've probably heard it 100 times. Muscle twitches after exercise? Just fatigue. Drink some water, stretch it out, you'll be fine. But that explanation skips over something incredible. Your muscles don't just get tired and twitch randomly. There's an entire electrical drama unfolding inside your body. A story with real stakes, a real villain, and a resolution that reveals how sophisticated your nervous system actually is. Let me walk you through what really happens from the moment you finish your last rep to the moment that twitch finally stops. Picture this. You're halfway through a heavy squat session. Every time you descend and push back up, your brain sends a rapid-fire sequence of electrical signals through your spinal cord, out through motor neurons, and into hundreds of thousands of individual muscle fibers in your quads, glutes, and hamstrings. Each motor neuron controls a bundle of muscle fibers called a motor unit. Small, precise movements use small motor units, maybe 10 fibers. But heavy squats? Your body recruits the big ones. Motor units controlling hundreds of fibers, all firing in coordinated waves. Your nervous system is running at full capacity. Every ion channel is working overtime. Sodium rushes in, potassium rushes out. Calcium floods the muscle cells to trigger contraction. It's a beautifully orchestrated electrical symphony. But every symphony has a cost. Here's where it gets interesting. As your workout continues, 3 systems start degrading simultaneously. First, your electrolyte reserves are draining through sweat. Every drop of sweat carries sodium and potassium, the exact minerals your neurons need to maintain their electrical charge. As levels drop, the voltage threshold for firing a nerve impulse decreases. Your neurons get twitchy, literally. Second, the ion channels themselves. Those tiny protein gates that open and close to let charged particles flow. They're getting worn out. They've been cycling thousands of times per minute. They start to misfire, opening when they shouldn't, failing to close completely. And third, here's the part that changes everything. Your spinal cord has been cranking up its own sensitivity. It's called central facilitation. During exercise, your spinal circuits amplify incoming signals to make your muscles more responsive. It's like turning up the gain on a microphone. Great for performance, terrible for what happens next. You rack the bar, you're done. You walk to the bench and sit down. But your nervous system? It hasn't gotten the memo. Your spinal cord is still running with the gain cranked up. Your motor neurons still have depleted electrolyte buffers. Your ion channels are stuck in various states of dysfunction. And then it happens. A motor unit in your quad fires on its own. No command from your brain. No signal from your spinal cord. Just a rogue neuron with a hair trigger pushed over the edge by a tiny random fluctuation in membrane voltage. That's a fasciculation. And once one fires, it often triggers a cascade. Neighboring motor units, already on edge, pick up the electrical noise and fire too. It's like one car alarm setting off every car alarm on the street. This is the peak chaos window, roughly 10 to 30 minutes after your last set. All 3 failure modes are maxed out, and your muscles are twitching like they have a mind of their own. Your body's recovery system is remarkably elegant. Within minutes of stopping exercise, your sodium-potassium ATPase pumps, tiny molecular machines embedded in every nerve cell membrane, ramp up to full power. They start physically dragging sodium out and potassium back in, one ion at a time, restoring the proper voltage gradient. Your kidneys shift into conservation mode, hanging on to magnesium and potassium instead of filtering them out. And magnesium plays a crucial role here. It blocks calcium channels in your nerve cells. Since calcium is the trigger for muscle contraction, magnesium is essentially a natural muscle relaxant that your body produces on demand. Meanwhile, your spinal cord gradually reduces its gain. The central facilitation that was amplifying everything slowly dials back to resting levels. It's like someone carefully turning down the volume on a speaker that was cranked to 11. The twitch is slow. The intervals between them get longer, and eventually, the electrical storm passes. Your nervous system returns to its baseline state. The whole process takes anywhere from 30 minutes to a few hours, depending on how hard you pushed and how well conditioned your system is. Post-exercise fasciculations are almost always benign, but your body uses the same twitching mechanism to signal real problems, and the difference is in the pattern. Benign exercise-related twitches are random. They jump around, hit different muscles, and resolve within hours. Concerning twitches are persistent. Same muscle, same spot, for days or weeks. That pattern can mean a nerve is compressed or irritated. Maybe a herniated disc pressing on a nerve root, sending constant errant signals to one motor unit. If persistent twitching comes with actual measurable weakness, not post-workout soreness, but genuine loss of strength in a specific muscle group, that's a combination worth investigating. And widespread fasciculations at rest, happening without any exercise trigger, paired with muscle wasting, represent the far end of the spectrum. Conditions like benign fasciculation syndrome affect millions of people and are completely harmless. But understanding the pattern difference empowers you to know when your body is cooling down versus when it's asking for help. Random, transient, post-exercise, your neurons recalibrating. Persistent, localized, progressive. Your nervous system waving a flag. Your body is an electrical machine, and after every hard workout, it goes through a controlled shutdown and reboot. Electrolytes restoring, ion channels resetting, spinal cord dialing back. Those twitches aren't a malfunction. They're the reboot process itself. You're feeling your nervous system coming back online. And now you know the difference between a healthy reboot and a distress signal. Random and short-lived means everything is working as designed. Persistent and focused means it's time to listen more carefully. Now you can read your body's electrical signals like a pro. Subscribe to Body Decoded so you catch the next deep dive into what your body is secretly